Alright, so let's write the formulas of these acids. Now, when we're writing the formulas of acid, we know that it's an acid because it ends in acid. Okay, and we know that all acids are going to begin with hydrogen. And remember, acids we're going to do just like we do on ionic compounds. We're going to crisscross. Okay, except we'll make it easier here because all acids have to have hydrogen, so we're crisscrossing everything with hydrogen. So we know that we're going to crisscross it. And remember, hydrogen oxidation number is just +1. So we're always going to crisscross it and crisscross it with hydrogen. Now, all we have to figure out is we have to figure out, well, what do we crisscross it with? Now, there are two types of acids. We have binary acids and ternary acids. Binary acids will always start with the prefix hydro. Like you see right here, it says hydrofluoric acid. So we know that it's binary, meaning it's hydrogen plus one single element. Okay, so we have hydrofluoric acid. So this fluor used to be fluorine. Okay, so it's F. So if we ever see hydro, we know it's hydrogen plus an element. So this is fluorine, and we look at fluorine, its oxidation number is -1. So we go ahead and we crisscross these guys, and we get HF, which is hydrofluoric acid. Now, over here, we see that we don't have the prefix hydro. This is that other type of acid, the ternary acids. And whenever we have a ternary acid, it's going to be bonded to a polyatomic, that hydrogen bonded to a polyatomic. And general rule is the polyatomic that ends in 8 will always change to -ic, and the polyatomic that ends in -ite will always change to -ous. So if we look and we see that this has sulfuric, so it used to be 8. So this is sulfate, which if we ever polyatomics memorize, it's SO4 with a -2 charge. And then we just crisscross these guys like normal, and we get H2SO4. Okay, now our last one, we see that it is -ic as well. So it used to be 8, which was nitrate. So nitrate is NO3 with a -1. We crisscross here, and we see we get HNO3.